All right, guys, this is Chapter 5 notes. So if you haven't done so already, go to Schoology, load up your, go into Schoology and go to your Unit 1 folder under Chapter 5, the Chapter 5 notes. I believe there's Part 1 and Part 2. If you just want to put those into your Notability, and then you can kind of follow along and copy this down as I go through this. It's going to be pretty quick as there's not a lot to Chapter 5. The only thing we're going to talk about in Chapter 5 is learning how to do box and whisker plots. So, a couple of things that we'll learn much more in this chapter than what you've done before is we're actually going to figure out in this chapter how we determine whether it's an actual outlier. So far, we've just kind of guesstimated and decided, okay, you know what, this sounds like an outlier, this looks like an outlier, so we'll assume that it is. But today we're going to figure out exactly how to do that and whether we have an outlier, a far outlier, or if we have any outliers at all. Okay, so let's start with box and whisker plots. And a box plot, again, it's essentially a graphic display of the 5-number summary. If you remember, this over here is your 5-number summary, the minimum, the Q1, the median, the Q3, and the max values. And again, you find those 5 values from plugging in your numbers into your calculator and going to stat, go right to calculate, and go down to number one variable statistics. And again, these can be created horizontally or vertically, either one. A lot of the ones we're going to create are going to be horizontal, so they're going to be left to right. Ideally, it's the best graph to summarize quantitative data, okay? And so it's the easiest graph to take a look and make summaries about it. An outlier is any data value that's beyond a fence. It's represented by an open circle. Okay, now we have 2 types of fences. We have the upper fence and we have the lower fence. The upper fence, to calculate the upper fence, we take Q3 plus 1.5 times whatever the IQR is. And then the lower fence is Q1 minus 1.5 times the IQR. Okay, and so what we do is we calculate those 2 fence values, the upper fence and the lower fence. Anything above the upper fence or below the lower fence is considered an outlier. Okay? The fences are never drawn actually as part of your graph, and you'll see what you'll see me do is you'll see me put them in the bottom of of your graphs on the box and whisker plots. I won't actually put them in the graphs, I'll put them on the bottom. A far outlier is used with the star symbol. Okay? The far outlier is Q3 plus 3 times the IQR, or Q1 minus 3 times the IQR. Okay? So that's how you determine if it's an outlier. Instead of 1.5, it's 3 times. So let's take a look here at some of our examples of what a box and whisker plot will be a part of. Okay? Let's first start with the box. Okay, the middle part of the box, when you actually draw these out, you're going to draw the box out first. So you'll put down a line for Q1, you'll put down a line for Q3, and you'll put down a line for Q2, and that makes up the main part of your box. Okay, so the difference between Q1 and Q3, essentially, guys, what you figure out is the box is your IQR every time. Q3 minus Q1, the distance between the two as we go along. Then, the whiskers go out to your maximum value as long as there is no outliers. Okay, so it goes, the high side will go to your maximum value only if there's no outliers. If there's outliers, it'll go to the next highest value. The minimum value, okay, the left side whisker will go to the minimum value unless there's any outliers. If there's outliers on the low side, then your minimum value will go to the next value that's there. And you'll see that as we go along here. These are examples of outliers right here. This is your lower fence dotted line, which we'll put underneath of your graph. This is your upper fence dotted line. Outliers are open circles that are above or below. Far outliers are stars, again, above and below as we go along here. Okay, now, a couple other things about your box and whisker plot. 25% of your data is always from the minimum to Q1. It's broken up into 4 parts. Another 25% of your data goes from Q1 to Q2. Another 25% from Q2 to Q3. And another 25% goes from Q3 to your maximum value. Okay? So it's broken up into 25 percentages. Now, how those spread out can be all different kinds of things. Okay? All right, how do we make a box and whisker plot? It's very simple. You start with drawing on a single axis, so drawing a number line, okay, spanning the extent of your data. Then you draw short lines, the first and the third quartiles, and at the median, and then you connect to make the boxes. Then you determine your fences and you draw dashed lines below. Those don't go on the graph. I know they're up here like this, but these go below the graph. They aren't part of your graph, okay? So you calculate your fences, determine whether or not you have any outliers. If that's the case, you add your outliers by displaying any data beyond the fences. That's only if you need it. Okay? So, the other thing you do to finish it up, you draw the lines from the ends of the box to the most extreme data values found within the fences. Okay? All right, so let's take a look at an example here. All right, I'm at the bottom of that page now, and what I have done is I have rearranged the numbers in numerical order, and what you'll want to do is you will want to take those numbers, put them in the calculator, okay? You want to make sure you calculate your 5-number summary. So I've done that part right here. I've got all these numbers in order. Put them in the calculator. Here's my 5-number summary like so, okay? I found the IQR. That's Q3, which is 93, minus Q1, which is 84.5. And then I've also calculated the upper fence. So the upper fence in this case, if I show you here, the upper fence is very simple to calculate. All right. So the upper fence is Q3 plus 1.5 times the IQR. Well, Q3 in this case is 93 plus 1.5 times the IQR is 8.5. So if you plug that in your calculator, you end up with 105.75. So any number above 105.75 is going to be considered an outlier. Okay? So right now, this number, 108 and 111, are both outliers. These are box plots for the given golf scores of 12 golfers. Okay? So now I got to do the same thing with my lower fence. So Q1 minus 1.5 times the IQR. Okay? So Q1 in this case is 84.5 minus 1.5 times 8.5. And when I do that, I calculate, I get a number of 71.75. So there's no numbers that are below, okay, no numbers that are below 71.75. So I do not have any outliers on the low side, okay? I do not have any outliers on the low side. All right, so I'm going to make this number line. I have to go from, I'm going to probably go on my number line a little bit below my minimum and above my maximum. Okay, so as I start here, I'll probably start at, 75 if I wanted to, and actually 71, so I'll probably start at 70. And you want to try to make sure your area principle here applies. So that's 70, that's 80, 90, 100, 110, and 120. Okay, so I know my upper fence, and I'm going to put this as a blue dotted line. My upper fence is 105.75, which is right there. My lower fence is 71.75, which is right there. So any number above 105.75 is considered an outlier. So one last thing I have to check here is there a number that could possibly be a far outlier? Because I do have some outliers. So to see if it's a far outlier, I take Q3 plus 3 times 8.5. Well, Q3, again, is 93 plus 3 times 8.5 is 25.5. Okay? So if I take 93 and I add 25.5 to that, I end up with, let's see here, 118.5. Do I have any numbers above 118? No. So I do not have any far outliers. Okay? So to make this box and whisker plot, what I'm going to do, I'm going to start with my median. Okay? Right above my median is 88.5. So that's going to go right here. I'm going to draw a line for that. Then I'm going to draw a line at Q3, which is at 93, which is right there. Then I'm going to draw a line at 84.5. That's my Q1 right there. And I have now drawn the box. Okay, so now I got to draw, let's start with the minimum side. Since I don't have any outliers to the left, to the low side, my whisker is going to go all the way to the minimum. So my minimum value is 79. My whisker covers like so. Okay. Now, what numbers do I have outside of the far outliers? Well, I've got 108 and 111. So at 108, I'm going to put an open circle. And at 111, I'm going to put an open circle. Those are my two outliers in this case. Okay, so the next number below my two outliers is 95. That becomes the number that my whisker is going to go to, because that's the next highest number inside the upper fence. Okay, and so now you have now created your first box and whisker plot. Okay, so put the numbers in order, calculate your 5-number summary, figure out if you have anything above or below the upper and lower fences, and then be able to draw your box and whisker plot. Okay, last couple things here in this unit, or in this chapter. Again, box plots can provide a couple of different things. They can provide central tendencies, they can show the spread, they can hit at the shape, and they can easily see any outliers. That's the great thing about box and whisker plots, is you know for sure whether you have any outliers or not. Okay? Now, there's 3 types of essentially shapes you're going to see. Symmetrical, which is pretty obvious. Right, left, pretty much the same, close to. You've got skewed right. Okay? Think about this. Skewed right means 50% of your data is over here on the left. Most of your data is on the left, and it skews itself to the right. Skewed left, 50% of your data is on the right. Really close together, and then it skews out to the left. That's where the tail's at. Okay? Each quadrant represents the same amount of data. The values represented in each section gives clues to the spread. Okay? So this is 25%. That's 25%, 25%, and 25%. So a total of 100. Okay? So when comparing graphs, so for example, if I were to give you 2 box and whisker plots together in the same graph, I'm going to ask you to compare some things. So you got to tell me something intelligent. In other words, you're looking to comment on specific things. So you're looking to comment on the overall median, the center values, use the maximums versus the medians, all those kind of things. Some things you can comment on. You can comment on the range, the most versus the least. You can comment on the IQRs. And you can comment on if there's any unusual features or any outliers. Okay? So when I compare 2 different things, those are some things that you can comment on. Okay, so last part here that we're going to talk about is I've given you two graphs now. See, I've given you two box and whisker plots, and it shows the speed in miles per hour of roller coasters. Okay, so you've got the wood roller coaster data up here, and you've got the steel roller coaster data down here. And it asks what percent of wood roller coasters traveled at least 67 miles per hour. At least 67 miles per hour means 67 is the minimum. So you want 67 or more. Well, 67 is approximately right there. And that's from Q3 all the way to the maximum. Well, what percentage of that data is that? From Q3 to the maximum is 25%. What percent of steel roller coasters travel at least 82 miles per hour? Okay. 82 miles per hour is approximately right here. Okay. And at least 82 means 82 or more. So from here, this direction is how much percent? Well, it's 25 here, 25 here, and 25 here. 3 sets of 25 gives us 75% total. Okay. In general, do steel roller coasters travel faster or slower than wood roller coasters? Justify your reasoning. Okay. This is what I was talking about making something intelligent, some kind of an intelligent comment here. Okay. And when we're talking about that, we're talking about, let's compare some things. First of all, let's compare maximum versus minimum. All right. The maximum roller coaster speed for wood is approximately 77, 78. Well, that's still not as fast as the minimum roller coaster for steel at 80. Okay, so you know, in this case, that's a good argument for why wood is slower, or in other words, steel is faster. Okay, another comment you can make. The maximum for wood is less than the median for steel. Okay, that's the middle value for the steel roller coaster. The last part you can look at, obviously, you can say, you know what? If you look at the maximum speed for the roller coaster for steel is 135 miles an hour, and the maximum speed for wood is 77 miles per hour. That obviously tells you that steel is faster. Okay? Those are three good examples of why steel roller coasters are faster than wood. Okay, to finish up the last part here, we're going to talk quickly about outliers, some cautions, and some things. You do not have to worry about the time plot part of the graph. You don't need to worry about any of that stuff. We're not going to mess with time plots. Okay? But the other part you got to be careful with is outliers. And so you got to be cautious. These are some things you never do with outliers. You never silently leave an outlier in place and proceed as if nothing was unusual. Okay? You can never just drop an outlier without comment. An outlier is an outlier for a reason. It happened. Okay? So you can't just take and make it disappear and be like, oh, hey, everything's fine. No, that doesn't work that way. Okay? So a lot of times calculations are performed twice. Once with outliers and once without outliers. Simply to see what the outliers do for a difference and how they make a difference in your data values. Okay? Okay, so hopefully this will help you figure out Chapter 5. Your assignment's going to be the Chapter 5 practice. It's going to be 2 sheets that you're going to put in the same document on Notability. It's going to be creating some box and whisker plots, comparing, and then also being able to just read box and whisker plots, being able to tell me what the Q1, the Q3, the median, the maximum, and the minimum are. Okay? Hopefully this should help you with Chapter 5.